teach you before I do multiply divide. Okay. All right. Welcome back. Math 1, 2.8.1, operating on functions. So basically, if you have two different functions, right? Say one function is 2x, the other is 5x. And I said, well, combine those. I want you to add those functions together. You have 2x and 5x. You combine them, what would you have? 7x. You see how easy that idea is, okay? When our functions are a little more complicated, here it's a linear equation, 2x plus 3. Here it's 3x squared plus 1. You have a little bit more to deal with, but the main thing, like kind of like prerequisite skills, so this is a remember, write this down somewhere. Remember that we can combine like terms. Okay? And let's just do a real quick one like this. Let's see, x third, x squared, 5x to the third, 3. All right. Yeah. Okay. We got a few terms here. I'm going to make this 5x squared. Okay. Now, which of the terms, somebody give me a pair, one from the left and one from the right, that is a like term. Yes?
5x cubed and x cubed.
Good. And we look there, the reason why these are like is the exponents tell us which ones are alike. Which ones are alike. Okay? So that would be based on the exponents. This is all based on similar exponent. Okay? So that's key. That's key. We can only link the ones that have like terms because of the exponent being the same. Okay, now what's another? 3x and x. You say, well, there's no exponent to that x, but yeah, it's a first exponent. It's x to the first power. We have 3 over here. We have 1 over here. If we combine them, we'd have 4x. Right? All right, someone new has another? Nate.
I forgot what it is. X squared and 5x squared.
You got it. You didn't forget. You were just trying for, like, the timing of that. Okay, perfect. X squared, second exponent. We combine those. 1x squared and 5x squares. If you add them, you get 6x squares. You see? Do you see what we're combining now? What's left over? The 3. Numbers, we can only combine with numbers. This is a constant. If I had 11 over here, I can combine it with 11. But if we don't, so that's the odd person out. Okay. Wow, training. I didn't say odd man out. I said odd person out. You see that? Catch that? I'm involved. Yes?
Where'd you get those numbers from?
I made them up.
Oh, okay.
Yeah.
I thought I got spaced out.
No, it's fine. It's the best answer. Okay. Everyone have this down or got the concept? I'm going to erase it. Yeah? Okay, another second. All right. The same thing is going to happen with these problems because we're going to have to combine like terms based on what it's asking us to do. You see this function notation here? We never have to add. We don't have to, like, this isn't multiply. This is telling us what we're combining. This is never really part of the equation that we solve. This is how we set it up. And we write these out with this function notation to remind us what we're doing. It just helps us remind us what we're doing. Okay. I'm going to erase this now. All right, get it from your neighbor. If you didn't, I I could have written it somewhere else. I didn't. Shoulda, coulda, woulda. All right, here we go. F plus g of x. What is that equal to? It's equal to f of x. Plus what? Plus g of x. You see? It's just the two functions added together. When you have addition, there's nothing to worry about as far as your signs go because you're just adding it. When we get to subtraction, we've got to worry about the subtraction part. Yeah.
How do you know when to put a subtraction sign and an addition sign?
Like, how do we know what operations happen?
Yeah.
So look at this one and tell me what's the difference between this, f plus g of x, and
the sign.
so based on this is almost like our map, what we're going to do with the two functions. This is f minus g of x, that minus that. This is f plus g of x, that plus that. It's based on the notation. So you look to the notation, you know what to do from that.
Okay, so it's just like, it's going to be there.
It'll be there. It'll be given.
To us?
It'll be given.
Okay.
What can I combine here? What combines with 3x squared? Anything? Nothing. What combines with 2x? Nothing. What combines with 3? 1, which gives us, there it is. She's in the future. Now we're with her. All right. That's our answer. Please get in the habit of just squaring it out because this stuff has a lot to it. I want to see it squared out, please. Now, with addition, you're practically all you're doing is combining like terms. That's the name of the game when you have addition. Combine like terms, right? All right. Subtraction, I want you to tell your neighbor, why is subtraction, honestly, it's going to be like twice as hard. Why is subtraction, addition was pretty straightforward. Why is subtraction different? Tell someone around you. Why is it different? What do we have to watch out for? All right. Kim, what'd you hear from others? You knew I was on the phone.
Subtracting's harder than adding. I don't know.
Oh, just in general. Okay. Hey, that's true. Subtraction, you have to think about the positive negatives, how we subtract them, signs. What's another thing we can add to that? That's good. Anyone else?
You have a negative number.
You can end up with a negative number when you have subtraction. Maybe negative and positive numbers mess us up a bit. Okay. I'm going to write this out. I want you to tell me if it's right or not. I'm going to write this out a little lower because we're running out of room. F minus g of x is equal to 2x plus 3 minus 3x squared plus 1. Tell your neighbor if you think that's right. I'm kind of setting this up. Notice I'm setting this up, right? So is it likely right? Why is that not right? I'll tell you, it's not correct. Why is it not correct? You see it now? Got it? One second. Jude, you got it? Okay. All right, let's listen to Jude. He has an idea. Jude, why isn't this correct?
Because 1's supposed to be a negative.
I see. So I'm going to go one step back because you are in the future a little bit too. Everyone's time traveling today. We have to put a parenthesis around that second one because it's minus that entire other function. If you need to just have that as a rule, I want you to put an arrow to that and put an arrow and say, because it's subtraction, you need parentheses. Okay? Because what do we have to do now? Jude, what do we have to do in what you said? It implies you know the next step. So what is the next step?
You have to multiply, add the negative to both of them.
Not add.
Or multiply.
Multiply it. Multiply the negative to each one. Watch. This negative applies to the 3 and it applies to the positive 1. We have to multiply both terms by that negative because we're subtracting. That's the key difference. All right. So let's see what we have then. 2x plus 3. What is a negative times a positive?
Negative.
Ooh, what a perfect delayed reaction. What is negative times a positive 1? Negative 1. Who needs to be reminded of the positive times and negative rules? Anybody? Have I told you the rules of dating? Do you guys know the rules of dating yet?
No.
Opposite
Can you
Would you like me to elaborate?
give us a life lesson, Mr. Steve?
Here it comes. Ready? If you're in a good mood and your date is in a good mood, what kind of date is that?
That's a good mood.
Probably good. You got like a 50% chance. Just kidding. Being good. All right. What if you're in a good mood, but they're in a really bad mood?
That could be a bad date.
You can see how this is oversimplified, but there's two options here. What if you're in a bad mood? They're in a good mood. Negative. And it's like you can't really change it too much. You're in that bad mood.
Maybe you could put them in a good mood.
There it is. All right, you both came to my class on Tuesday after a 3-day break, and I had a pop quiz. You both failed the quiz. You can go out on a date, you're both in a bad mood, but what's your common goal during this date? To talk about?
Study.
Rat. To destroy.
Math.
Say again?
To destroy.
To destroy me. You're going to complain to each other on how Mr. Pasillas wasn't fair, and then you make each other feel a little better. You ever have this? Like when you're talking to someone and you can complain, or you have a common enemy, you're both mad about something, you talk it out, talk a little smack, whatever you want. Ends up being what kind of date?
Good day.
Good day.
You'll thank me when you all are, happily married with 7 kids.
7 kids.
Don't do that.
That's why.
That doesn't even fit in like most cars.
Oh.
Your significant other would have to stay home. All right, let's check this out. You do whatever you want, but just remember the rules of dating. What goes first, guys? Negative 3x squared. You see how it's the second power? What combines with that? Nothing. How about the 2x? Nothing. You see how it's the first power, second power, first power. What's last? 3 minus 1? 2. What do you guys think? Thumbs up, sideways down. Can we do these? Okay, what's the hardest part? Someone give me Candy Crocs. Come on, get those cavities. Yes?
It's a subtraction.
Subtraction. Because you got to remember the parentheses, you got to remember the negative, you got to remember the rules of dating, and then you get all distracted. You start thinking about your crush, and you're like, dang it, what am I doing? Good job. Thank you for kind of laughing. Thank you, thank you, thank you, thank you. I'll have many more, don't worry. If you missed that.
Yes.
Yes. All right. Let's do these. I'll set you loose, and you'll have plenty of time. Oh, yeah. You have plenty of time. You have like 15 minutes. Okay. So we're going to do this for about 10 minutes, and then I'll set you loose on the classroom. All right, I want you guys to set up, just set up this first one. F plus g of x. Here's my f of x, here's my g of x. It's different than the first examples. Set it up first. If you want to solve it all the way up, that's fine. And you know what? Actually, I need to change this. I need to make it a little bit trickier. Ooh. I know. Take a deep breath. All right, good focus. Keep it up, work it all the way up. You need to show a little bit of work. You need to show a little work. If you can do it all mental math, I want you to have a process before it gets more complicated where you can't do that. So you're writing out at least like a second step, and then your answer probably can come after that. All right, I'll start it out. One function plus the other function. That's all we're doing. Okay. It looks like too much. Sometimes we're here and we're thinking, looking at all the terms at once makes it harder. So I look for my biggest term because I know the biggest term is going to go out in front. It's going to go first. So I'm just going to circle it. I'm showing the process. Maybe not everyone needs that. But I look at the biggest term we have. The exponent's the biggest because I know that goes first. So is there anything that matches with this term? Nothing, right? So I'm going to cross it out to keep track of what I'm doing. Make it nice and clean. Okay. What's the second term that's going to be in order from greatest exponent to least exponent? What's my next one, Jackie?
4x.
Good. So I look here, 4x. What does that connect with? Positive 2x. I can connect those and get perfect. Cancel them out so you know you're done. What's last? This one. Okay. So I want you to get in that habit of squaring it out because if it get complicated, go ahead and square that out. You can see it quickly. Okay. Anyone have a question on that? No. Get it? Get it. Tomorrow will be a little trickier, but let's keep on today. Actually, I want to be in the future too. We can't be in the future. I want you to set up number 2 here. I know that 2x plus 1 is going to be there, but that's the easy part. The second part is the harder part. So I want you to go ahead, work that all the way up, and then we will reconvene. You guys already did it? Yeah. It's true. It's true. Good point. Good point.
Are you recording?
How's your what?
Are you recording?
Of course.
Can you upload this actually?
Oh yeah. I upload everything. I don't care what's on it. I'm gonna email it to your parents and be like, "Look what Nate's doing in class."
Oh no, don't do that. My mom hates when I do. She's like, I know you do it in class.
What's your mom's name?
Christina.
Christina. Did you hear that? That was your son. He totally did. Now I gotta email her, just see what happens. I just want to see what happens. Sorry. Just a joke. And all right, what goes in the second one with parentheses? Nate, what do you think?
2x squared plus 4x.
Perfect. Now the next step is maybe the hardest step.
X.
I've seen if you watch it. All right, what are we gonna do? Leah, help us out all the way through.
You multiply the negative out.
Perfecto. And we get 2x plus 1. What else?
Minus.
2x squared.
-.
That's from second period. Wait, no, she's not in here. I was thinking that again. Perfect. We got negative 2x squared. What's next, Leah? Okay, very good. Quinn, what matches with negative 2x squared? Nothing. Move it down. Okay. What matches? What's our next term? We got the second power. Then we go to first power. Now let's look at this. You got positive 2x. You got negative 4x. You're underwater 4 feet. You go up 2 feet. Are you underwater still?
Yes.
Yes. How far underwater?
-2.
Negative 2 feet down.
Lastly, plus 1. All right. We got addition and subtraction down. Thumbs up, sideways down for doing these 2 types of processes. All right. Okay, so tomorrow we will do the second half. This is a part 1. Tomorrow has a little more to it, but I think we're going to actually keep that the scope of this week. Okay? Let's see. Can we all whistle?
Yes.
All right, let's just let's whistle this out. Everybody whistle. All right, that's enough whistling. It was all Nate's inspiration.